Hello, class. This is Mr. Hart. In this podcast, we want to start the end of year topic for chaos theory. Okay, and the reason I chose this as one of the options for the end of year topics is because I feel like chaos theory is one of those things that has been very poorly portrayed in movies and literature and things like that. It's kind of just one of those buzzwords people throw out there because they don't really understand what it is. A lot of people just think chaos means things are flying around everywhere and it has no rhyme or reason to it. But in reality, we can actually predict things that are in chaotic systems, but we have to do it in a certain way. And so the reason we're going through this unit is so that you can understand what it means and how it affects physics and things like that. Okay? And so you're not just another person that thinks chaos theory is some weird thing that we can't understand. Okay? So what we want to do is before we get into chaos theory and what it is, we have to understand how physics works at a higher level. Okay, we've done a lot with first year physics and working with equations and things like that, but we want to be able to understand how physics starts to work when you get higher up in the classes, when you get into college, if you go into physics and things like that. Okay, so you probably remember when we went through like momentum and energy, I've shown you this table before. Okay. And I call it the three kinematic quantities, and it's kind of the three different ways we think about motion in physics. Okay, so when we think about motion, there's three things that can kind of affect it. It's the force on the object, okay, or the momentum of the object, or the energy of the object. Okay, and I've said previously that like these are kind of independent. You don't have to calculate all three. You can just think of terms of one or the other. Okay, if you're doing a momentum problem, you don't have to do it as a force problem, or if you're doing an energy problem, you don't have to worry about the momentum and things like that. Okay, I've said that they have kind of their different uses, like force is often for statics, momentum is often for collision problems, and energy is usually for dynamics. Okay, and so that's fine for first year physics, and even like first year college physics, usually we kind of think of them independently. Okay. But in reality, when you get higher up, you'll learn that these quantities are very closely related. Okay, instead of being three separate things that we measure, we realize that they're very interconnected in how one affects the other, right? So the force is definitely going to change the momentum of an object or the energy of the object and stuff like that. Okay, so our equations aren't as simple as we see in first year physics. Okay, and so if we go higher up in physics, okay, we start to see a higher level of what I call models, okay, or kind of mathematical equations that describe what's happening, okay. So down at the bottom we have our intro physics class that you do in high school, and we just have our three separate equations, right? Force, momentum, energy in all its different forms, okay. But as you get into AP physics and upper college physics, the equations start to change, okay. So notice in AP Physics, we still have F equals ma. That's kind of the basis in that class. But then we start to get a connection. Okay, so the change in momentum, for example, is dependent on the force. Okay, and the change in energy is also dependent on the force. Okay, we can think of it in terms of force. So another thing to notice is that we're using calculus here, right? We got these integral signs, and so the math starts getting harder as you go higher up in physics. And then by upper college physics, we got what we call partial differential equations with time derivatives, and we have what we call general coordinates and things like that, right? And so if you can't read these equations, that's fine. You're not supposed to be able to, okay? But we start to get more math intensive, okay? And so as you go higher up, the different quantities, force, momentum, and energy, become more interconnected, and the math starts to get more difficult. So why am I showing you this table? What's the whole point of showing all these mathematical equations? The reason is I want you to understand just one key idea, okay? That as you go up in higher in physics, okay, if you want to be able to represent more situations, more scenarios, you want to represent something that's not traveling in a straight line, that has friction, that has air resistance, that has these rotational inertias and things like that. The math has to get more intensive. It has to get higher level, okay? The more scenarios you try to represent, more general the model is how we say it, you have to have higher level mathematics, okay? And that's fine. That's why you go into higher level physics. You want to be able to understand these higher equations and things like that, and you go through the math classes to represent it, okay? But just realize the nice and simple algebraic equations we use in regular physics is not what we see in higher level physics, okay? So that leads to the first idea, right? The more general a model, okay, or a mathematical equation, the more situations it can represent, okay? The simpler the model, like we use in Intro to Physics, the less situations it can represent, okay? Or in other words, the more mathematically difficult, the more situations you can represent, and the less mathematically difficult, the less situations you can represent, okay? So that's just kind of the idea of physics, right? The higher up in physics you get, the more mathematically difficult the equations are going to get. So why does this relate to chaos theory? Okay, here's the whole point of this lesson, okay? This is the whole point. If you look at these equations right here, okay, these very high level mathematical equations, they're what we call partial differential equations, okay? And unlike in algebraic equation where you just plug in a number and you get an answer, these guys sometimes don't have analytical solutions, meaning you can't just plug in a number and get a nice simple answer back, okay? And so these partial differential equations, these higher levels of models that we use for physics, sometimes run into a problem, okay? And this is the main point, the whole point of this lesson that will lead us into chaos theory, okay? The point is, differential equations don't always give us analytical solutions, okay? And that means basically you can't plug in a number and then get an answer, okay? It doesn't work that way. It describes how the motion's behaving, but it's not as simple as plug in a number, get a result, okay? We have to use a computer to approximate it computationally, okay? And when that happens, basically what it does, it just has to go, step by step, millisecond by millisecond. Where's the object at this millisecond? The computer calculates it. Where's the object at the next millisecond? The computer calculates it. Where's the object at the next millisecond? The computer calculates it, okay? It has to do it step by step in order to get a result. We can't just plug in a number and say, well, where's it 5 seconds from now? We can't do that. We have to go step by step by step every millisecond until we get to 5 seconds down the road, okay? So that is why when we get into chaos theory, we'll see that we're limited in our prediction capabilities sometimes, okay? We have to use a computer. We can't just plug in an answer and get a result, okay? We have to use a computer to go down the line to get our answers, okay? All right, so I hope this didn't go too far over your head. But again, just recognizing these two main points that as you get into higher level physics, the situations we're trying to represent require higher levels of math. And one of those is differential equations. And when we use differential equations, sometimes we don't get analytical solutions that are nice and simple. Okay? All right, so hopefully that made a decent amount of sense. In the next video, we'll look at how this relates to chaos theory and what it means.